What's up, guys? So we're gonna make some stuff. Right now, we're about to machine these plates right here. This is a piece of. This is part of the exterior for the workhorse printer. Yeah, we got some stuff we're doing. Anyways, so it's gonna be a top plate for this exterior right here. So we'll see how it goes. Also, still working on the heated bed. Came up with a good solution for that. It's gonna be something like this. So this is the base plate right here, and basically the way it's gonna work is this right here. This is a metal protective barrier for the heated bed, and also got this insulation right here. So this is fireproof insulation, and basically this is the bottom of the printer. The printer's on its side right now, but basically there's gonna be a layer of insulation, and then it's gonna have this protective metal barrier, and then the base. The base is out of wood. That's why I have to have this metal protective barrier. But so imagine this. So imagine insulation right here, and so it's gonna have a layer of insulation right here. This is like a roll. Can't really see it too well, but so this is a roll right here. I got this from on Amazon actually. Fireproof insulation, made for like kilns and furnaces and stuff like that. But so that'll go right here, and then the base will have this metal protective barrier right here, and this will be the bottom of the printer. So I'm pretty sorry about that, but for right now, we are machining the exterior plates for the workhorse. I got a couple of these I gotta ship out. So we're actually shipping fully assembled printers starting this month. We got our first two, so I have no clue how that's gonna go. Probably gonna run into some problems. Hope not. But to start with, so I'm writing this program. This is what the plate's gonna look like, and so I got it cut out right here. It's 1/4 inch end mill. Then I'm gonna cut the left side, the right side. That's gonna use that 1/2 inch end mill, and then I'm gonna center drill these holes. And so I got a bunch of these plates I gotta make, and I kind of gotta free this mill up tonight, so I only have so much time. So what I'm gonna do, since it's just exterior, I'm just gonna center drill the holes. So I'm just gonna center drill the holes and then take it over to my trusty drill press here and just drill press the holes. It's gonna be a 5mm through hole. So we're gonna center drill it and then use a 5mm drill to drill through using the center drill indentions. So I don't need any kind of accuracy, which that's pretty darn accurate, really. As long as it's center drill, that should be fine. So, anyways, so here's my program, and go ahead and post the code. Grab the USB stick. I guess it's Sunday. Everybody's doing the whole Super Bowl thing. Um, I didn't even know there was a football game today. That's how like out of touch I am. I was talking to a customer earlier. He's like, "You're watching a game?" I was like, "What game?" And yeah, apparently it's Super Bowl Sunday. I didn't even know it. I don't even know who's in the Super Bowl. Not missing out on much. Um, I can't say that I'm not a football fan, but um, I don't keep track of it. I'll go to the game. Going to the game's no problem. But actually watching it on TV, uh, I got ADD. I can't sit down and watch a football game. All right, so this is what we're doing. Hopefully, my computer doesn't crash. Kind of funny. So a buddy of mine asked me the other day, guy I work with, actually got. I'm not sure if I can say I got a job slash partnership, but we are working at a different location now. Still working here. I still got my shop into my house, but um, anyways, one of my coworkers um, asked me what I do in my free time, and I thought it was hilarious trying to explain to him that um, pretty much I do CNC machining. But anyways, oh crap. All right, so well, for some reason, my center drill posted. Let me see what's going on here. Try to repost this. Alright, cut out, cut out. So I'm going to use a 1/4 inch mill to do the cutout, a 1/2 inch mill to cut the sides, and since it's just the exterior plate, we're going to use a center drill. So we'll see how that goes. Hopefully I got the tool numbers good, right? I'll go ahead and save it. Alright. Let's check this out. I don't want to show you all my customers. I got program names and the customer names. Let's see. Alright, so here's my G-code script. So we got the cutout. Basically, we're going to cut out clearance for a motor mount, for an EMA 23 motor mount. Then we're going to come down. That's going to use a 1/4 inch mill. So it's just going to cut like a big square here. Then it's going to have a 1/2 inch mill, come down, climb mill on this side, and it's going to come over here and cut on this side. And then we're just going to center drill some holes. So what we'll go ahead and do now is we'll go ahead and set the tools here. My mill's a little dirty. I've been super busy, dude. Like, it's ridiculous. So we'll go ahead and come down and set the tools. Let's see, tool 4. Let's see. 1/2 inch mill. I got it as tool 5. It's actually tool 4. So we'll go ahead and change that. Center drills tool 9. Let's check this out. Yeah, tool 9. Alright. So I don't use a probe or anything. I do it old school. I just set the tools on top. Alright, so tool 1 is the 1/4 inch mill. I don't have a 1/4 inch mill ready yet. Then tool 9. Let's go ahead and switch to tool 9. Alright, so tool 1, 1/4 inch mill. So we'll go ahead and grab a 1/4 inch mill. I don't think I have one out yet. Let's see. We got this long ass end mill. I don't think we'll use that. Actually, I know we won't use that. Actually, you know what? I got some new emails here. Where do we go? Alright, so let's see. I have some. No. Got a little kit here. Here we go. Let's try this guy out. Make sure it's 1/4 inch. Looks like 1/4 inch. Most likely 1/4 inch. Alright, cool. Alright, so we'll go ahead and find a tool holder. Let's see what we got here. Here we go. Shop's a little messy. I haven't had time to clean it. Well, I'm gonna blame that on Santi. Santi, clean the shop, man. Oh, he did clean it. Alright, so we're gonna go find a little collet. Just like that will work. Alright. So we're gonna put this in MDI. It's gonna be, what do we say, tool 1. So I'm gonna go to MDI T1 turret 4. Almost. Alright. Cut the shim. We always use a shim because we don't have to damage any end mills. So I got tool 1 right here. So I'm going to go tool offset measure. You can see it changed. There's some offsets. We'll delete these out in the tool area. Prevent any problems. All right. All right, so now we need an edge finder. Let's see. The mill's pretty dirty. I need to give it a bath, but I think we'll be all right. We can still make stuff. So now we gotta set our datums. We're gonna set our G54 X and Y offset. Alright. So we got our edge finder right here. And we're going to set our G54 right here at the front left corner. Kind of weird. It's showing up on the screen as the right corner. I don't know. Let me make sure we tightened all this down good. Ooh, it's a little loose. That's why it's always good to double check this stuff. It's tight, but we don't want it moving. All right. I kind of goofed up a little bit. So basically we gotta come in. We're gonna cut this side, we can cut this side right here. But when the tool travels over, um, I made a mistake. I told it only just to come up 100 thousandths above the part and travel over, and that would result in us gouging the clamp. So we don't want to do that. We don't have any crashes. Don't want to break any tools, especially on YouTube Live. So we'll go ahead and fix that. So just gonna do the cutout first. That looks good. Hold up. Right here. This number right here, we need to change that. So basically, whatever the height distance of our clamp, we need to travel up probably about 100 thousandths above it so we clear it. Now, the clamp should be a ½ inch tall, but let's go ahead and check that. Make sure. It's always good to measure, especially when tools get involved. Alright, so it's about a ½ inch. It's really a ½ inch. I kind of half-ass measured it right there. Okay, so this number right here, I'm gonna make it's a ½ inch, so 0.5 inch. I'm gonna add the extra 100 thousandths, so I'm gonna go Z 0.6 alter. So now it's gonna have clearance. So when it goes over to the right side, it should be fine. It'll finish up cutting right here. Then we have to worry about when it does the center drill cycle. So it's gonna come in, center drill here, 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 and here. So what we need to do is, we need to change our retract. I think it's, what is it gonna be? I think it'd be R. Total brain fart. I think it's either R.6 or R minus 0.6. Crap, I forgot. I guess we'll soon find out. So let's go ahead. Let's go ahead and just run this, see what happens. So I set the origin right here, but I need to cut this side, so I'm gonna offset everything over 50 thousandths. So I'm gonna go over here, go to offsets, go to my X 0.05, and enter. So I'll offset everything over. So even though I set the origin right here, it should be cutting that. Alright, cycle start. Looks pretty good, I guess. Kind of get a weird. I don't know what's up with that. Looks kind of weird. Now, I would normally cut faster and have the wrap. I kind of have everything turned down right now because this the first piece. Basically, there's something wrong in my code. I can screw some stuff up and break a tool or crash a machine. So I'm going kind of slow just because I'm cutting one piece. Usually the way it works is you prove out the program on the first piece, and then you bump everything up so the CNC is really faster. Um, that's just kind of a safety measure. But in this case, I only have one piece, so I'm actually machining a little slower than I normally would. So imagine this, but like 10 times as fast. So all you guys out there that are like, oh my god, he's machining slow. I actually get that. People are like, oh my god, you're machining slow. It's like, yeah, it's the first piece. If you're running one part, there's no sense in trying to be speed racer. Last thing you want to do is try to show off and go really fast on the first piece before you have the program proven. Okay, so I got a little issue. It didn't actually cut through. I don't know what's going on. Um, let's check our Fusion 360 file. Alright, there's our problem right there. So, in the Fusion 360 file, this should actually... Well, hold up. Alright, something's looking weird. Let's figure this out. So the tool didn't actually cut all the way through. We're about 50,000 shy. So the first thing I'm gonna do, let's go look at our code here. So right now we're at Z minus 0.04. Okay, so right here, it's only going to Z minus 0.175. Now the material is about 3/16, more like 5mm thick. See, we're almost through there. So I got two choices of what I can do. I can fix the file, which we will fix the file. I'm gonna go ahead and I'll measure how much more we have to go. So wow. All right, so so we cut about 132 thousandths deep. Let me measure the thickness of the plate. Make sure I got the right plate here. Plate is 0.199. We went 132. So we have roughly about another 70 thousandths to go. I don't know why I did that. It's kind of weird. Maybe probably did something wrong, but no big deal. So I'm gonna go ahead and double check the Fusion 360 file, and I'm not gonna worry about proving the like backing up, saving the G code. But what I will do is I'm gonna go ahead and for tool 1, I'm gonna go ahead and bump that down minus 100 thousandths. Also, let me Let me check the Fusion 360 file, because... Alright, so we're going to the model bottom. So we're supposed to be cutting to the blue line. I don't know what happened. For some reason, it's only going to Z minus 0.175. I don't know what's up with that. Let's measure the model. Ah, there's our problem right there. Our model is only an 1/8 inch fit. Alright, so I didn't draw this model up. One of my guys drew it up, and apparently he didn't draw it the right thickness, so he drew it a little thin. So even though it was programmed to go to the bottom of the model plus or minus a whole another 50 thousandths extra deep, for some reason it didn't. Yeah, the model wasn't actually drew up right, so no big deal. We'll fix that. Actually, we're gonna fix that right now. Alright, so I'm gonna go back to model. I'm gonna rotate this a little bit. I'm gonna double check myself. I'm gonna measure this one more time. 1/8 inch. So it's supposed to be about 200 thousandths. So we got, it needs to be about 75 thousandths longer. So I'm gonna zoom out a little bit. I'm gonna go to modify, and we're gonna pull this up 75 thousandths. Alright, let's go ahead and measure this again. And 0.2 looks good. So I'm gonna go save. We'll go back to manufacturer. Let's regenerate this code. And this is what happens when you have multiple people working on the same files. But anyways, for right now, I'm just going to subtract the tool wear down 100 thousandths, and we're just going to run this baby again. Alright. I'm going to put it on hold just for a second. Alright, so basically I want to get a little clip for the YouTube channel of this part being machined, so I'm gonna make an actual edited video. But let's try this out. So right now, it's showing that we're at Z minus 0.12. Okay. Okay, so the part cut out, and it kind of got wedged in between the end mill. No big deal. Here, we're gonna fix this real quick. I got screwed up trying to hold two cameras at one time. Ah, jeez. Hold on 1 second, guys. I knew this was gonna happen. Alright, cool. Alright, so what happened was I cut the part out, and usually what I do is I'll leave like a little tab for it, and I'll come in and I'll cut it out by hand or something. But I was trying to get fancy and hold two cameras at once, and I kind of didn't catch it. But anyways, no big deal. So I got a burr right here. I got a little build up in my end mill. I could either rerun that, which there's really no sense because that burr will kind of pop off. So we're just gonna kind of go with it for right now. I knew I should have been holding two cameras. And this is one of the lovely things of running unproven programs that you just post. Usually what you want to do is you want to basically post the code and safely, follow all the safety steps, like run a dry run, run a rapid, keep your finger on feed hold, and pretty much watch and make sure that wherever you actually posted, the machine actually does. But the code was actually all right in this instance, except I should have been quicker to stop it. But anyways, I got a burr right here. When I pull this part out, it's not gonna be any big deal. Pretty much, I can just kind of bend it off and deburr the file. But anyways, let's see. Got a little build up in my end mill. Everything looks good. Anytime you have any little mishaps with the machine, you want to check, make sure everything's still lined up. Let's see what this looks like. So what I'm gonna do is I'm gonna bring back the edge finder and just make sure everything looks good here. Let's see. Tool 10. Alright, so I'm gonna double check my workpiece. I'm gonna come in, touch off right here, and touch off on this side and make sure nothing moved. We're probably fine. run the machine and hold the phone at the same time. All right, so I'm gonna check my Y value, 98 thousandths, and I'm gonna go ahead, go to the other side, make sure my workpiece didn't move. I kind of got it held in there weird. This is just a piece of exterior. Usually, hold your part like in a vise or super spacer or something like that. All right, looks pretty good. Kind of a crappy emu. Never actually had to do that before. All right, so I'm through with the cutout. Go over here to the left cut. Make sure our depth's right. So I'm going Z minus 0.3. And we're lifting up to clear the clamp. Alright, so I'm going to run into a little problem right here. The end mill isn't actually going to clear the nut that's holding the clamp down. So I'm going to have to change this. If I stop the machine and we look at this, basically what would happen is the end mill would crash right into the nut that's holding the clamp down. So we definitely don't want that to happen. Guys, I'm gonna be honest. It's been fun, but it's kind of hard to run the machine and live stream at the same time. So I think I'm gonna just quit live streaming here and actually get this job done, because it's already 10:30 and I got an hour and a half. I still got 3 of these plates to make. Each one of these different. I'm sorry, I got 4 more plates to make. Every one of them is different. And I still got to write programs here. But anyways, hope it's been fun. Hope you all have a good weekend. I'll see ya.